When it's about statistics, there's one thing everybody learns. It's a normal distribution. We accept it and apply it wherever we can, because it is easy to use and most tools, whether it is a mean or linear fit, require it. But are you sure that when you get out into nature you will find it? Let's look at more than just data. The normal distribution is also known as Gaussian distribution, named after Carl Friedrich Gauss, a mathematician living in the 18th and 19th century in the Kingdom of Hanover, which is nowadays part of Germany. This distribution is known by many for its distribution function, which has a typical bell-shaped form. With it we calculate and interpret many things, so that most of our standard statistics we nowadays use has directly or indirectly the normal distribution as an assumption. So let's see what makes it so important. Number 1. I won't bore you with the full equation, but the key element is an exponential function. It gives the curve its beautiful shape and also some very interesting properties. When you draw a line along the exponential function, known as a tangent or a derivation, or you determine the area under the curve, called an integration, the equation will always have an exponential function in it. And you cannot only do it once or twice, but as often as you would like. Exponential functions are simply very well handleable in mathematics, and so also the normal distribution is easy to use. Number 2. A second reason why the normal distribution is so much used is its part in something called central limit theorem. This theorem essentially says that when you sum up any distribution and those are not too strange, at one point you will get the normal distribution. You can show this with sums of dices, but I want to talk about precipitation values, so essentially amounts of rain. In many areas of the world, for example in the mid-latitudes, like most parts of the US or Europe, a histogram of daily precipitation values does not look like a normal distribution, but more like this. You got many days where no precipitation is recorded, so quite some days without rain. Quite a bit of days with low precipitation values are there as well, and a few with very high ones. When you would sum up infinite number of days, you are guaranteed to get a normal distribution, but it needs some time to get something which looks roughly similar to it. But there's also another problem, often ignored when using the normal distribution. When you go to the tails of the distribution, so to the far sides, they do not stop. Actually, they never stop, even when the rope stops here. You could go around the world, infinite far away from the mean of the distribution, and you would still find a finite amount of probability. This also means that when there is a limit on one side of the distribution, like for precipitation when there are no negative values allowed, technically it cannot be a normal distribution. Many variables we use to describe weather or climate, but not all of them, are behaving in a way like precipitation. The closest one to be a normal distribution at all is wind. But in this case, we are not talking about wind speed itself, as this has clearly with 0 a lower bound. In atmospheric science, you divide the wind into a component from west to east, called U component or meridional wind, and one from south to north, called V component or longitudinal wind. Each of them is in many regions close to normal distributed, while it often has a bias due to preferred wind direction at the locality. Nevertheless, we still like to use the normal distribution as our standard approach when we handle data. It is easy to use. So many standard tools depend on it, and indeed, many do not think too long about it before they apply it. But while the normal distribution is hardly ever exactly fulfilled, many tools can still be validly applied, as small deviations from the assumed distribution often do not lead to wrong conclusions. To know when this is the case and when not requires a lot of training and regular checks of the used datasets. Because one general rule applies: the normal distribution is not normal.